Hey everyone, in this video we'll be discussing what we mean when we call agents stateful or stateless, and you'll be hearing these terms a lot, especially in context of agents that are deployed and working in production. Now I wanted to defer discussion about agentic states until we were fully comfortable making API calls not just to OpenAI's models but also to other frontier models like that of Claude or Grok or even open source models like DeepSeek. But our hand has been forced by the response we got from Cursor Agent in our last video when we tried prompting Cursor Agent to give us ability to select which model we want to send our queries to, as well as other parameters for our API call. Especially the part which we need to focus on is in our class chat config. When we try to send a user query to OpenAI's API, it's obviously appending either a developer message or a system message which will serve as our instruction to the model, but it's also sending in our full conversation history along with the user query. And it's this part where our logic is not only tracking conversation history but is also sending it in our overall prompt that makes it necessary for us to understand agent states and memory this early in our journey. Let's go to ChatGPT first to just explore what we mean by agentic states. Let's ask it what's the capital of Italy, okay? And obviously it will respond with Rome. Now if I ask it, okay, what about Latin America? Obviously I'm expecting it to rebuke me because Latin America is not a country, it's rather a class of countries. Let's see what it responds with. Obviously, it pointed out that Latin America is not a single country, it's a region. But it still remembers that what I'm asking about is capitals, even though I have not included anywhere in my prompt that I want capital of Latin America. It seems it has remembered our previous conversation where we asked the capital of Italy and it responded with Rome. But that aspect of our conversation is an illusion. AI models by themselves don't have any capacity to remember stuff, okay? And that part is extremely important. Whenever any of these frontier companies, whether it's OpenAI or Anthropic or DeepSeek, when they come up with these models and they deploy it in the real world. So for example, OpenAI will take a year or couple of years to train any of their models, whether it's GPT-3 or GPT-4 or GPT-5. So they might take some time to train the models. And once the model is ready, they will deploy it in the real world where users can use it. At that point in time, when we have these models in the real world, like what we are using right now, what we have is an engine that is capable of thinking or reasoning. So it has some raw intelligence or reasoning capacity, but it doesn't have any capacity to retain new information. So imagine if we were a newly born child. So we have a certain reasoning capacity or intelligence that we are born with. And say, for example, on a given day, we learn numbers. So we learn numbers from 1 to 10. And then next day, we continue our learning by learning numbers from 11 to 20. Naturally, we tend to remember what we learned on the previous day. But imagine if a newly born child worked like an AI model. What will happen is, even though that child has learned numbers 1 to 10 on a given day, on the next day when you try to teach that child numbers 11 to 20, it would not have any memory of learning numbers 1 to 10 on the previous day. It will still have intelligence and reasoning capacity, but it will not have retained what it did or what it learned on the previous day. So what you then have to do is when you try teaching it 11 to 20 on the second day, you have to remind it that it also learned 1 to 10 on the previous day. And essentially that is what is happening when we engage in a chat session with ChatGPT or any other AI model. Is when I'm asking it, okay, what about Latin America? It's not that it has any memory of the conversation I had with it previously, but it's being forcefully reminded of the conversation that I had with it previously. And that is happening because when ChatGPT is sending this second message to GPT-5, it's sending both the first two messages, the user message and the AI message, along with our second message. And when we pass a third message in the same chat session, okay, say if I want to ask it capital of Senegal, okay, it will take this third message, but it will also pass this user message, this AI message, this user message, and this AI message to it along with this one. So it's kind of being reminded every time I shoot a new message to it of the conversation that already preceded that message. Okay, and it has again understood that what I'm asking about Senegal is its capital, and it inferred that not because it remembered the previous conversation, but because we made it remember the previous conversation by passing that conversation chain along with our most recent message. And that is what the response that we got from Cursor Agent agent is also trying to do, in that whenever we try to send a user query, it's also extending our messages by our existing conversation history and passing that along with our recent user query to remind the model of the conversation we have already had. And this is essentially what you can call a stateful agent that has a certain sense of memory because we are giving it that memory. It doesn't have any inherent state or inherent memory, but we are maintaining it by passing it in context every time we send a user query. And this will become even more clear when we look at the messages that we are sending to the AI model. So let's add some print statements so we can look into the messages in detail before they are sent to AI model. This is the point where we are trying to build our messages data structure, and it will have developer or system message depending on whether it's reasoning or non-reasoning model respectively. Okay, so let's print constructing instruction message. This is a point where we are adding conversation history, and at each point let us also print the message itself. Now we can also see that cursor is asking us to use tab to jump at this point, and it will automatically, I'm assuming, print messages, because considering we printed messages at this point after our instructional message is constructed, it's assuming we will want that to happen after extending messages to include conversation history. And this is another mode. So we have already used agent mode and we have used inline mode where we select a particular code snippet, and using Control K, we start an inline session to ask questions or make edits, which are much more localized in our code base compared to agent mode. And this is another way to use cursor, where we can use tab to use cursor's auto completion model. Cursor has its own autocomplete model, which is much more tuned with our local coding workflow. So the more we code and use tab, the more its auto completion model will get tuned to our coding style, which is unlike agent, which is far more comprehensive and free in terms of the changes it will make. This is much more localized and in sync with the way we like to code. So we will press tab and see what it suggests. And as we assumed, it is giving us this ghost message. And if we press tab, then it will make those changes. We are printing messages after extending messages with conversation history. And then let us also see, again, it's giving us a ghost suggestion here where we can use tab to accept it. And it's also now suggesting tab to jump to this point, and we'll oblige. So it's basically just trying to segregate different messages that we are printing, because we have used this snippet before in other areas of our code. So if you look at this part, anytime we are trying to output something on the command line, it's segregating them using this logic. Because tab is much more localized in terms of what suggestions it offers to us, it has assumed that we like to use this every time we are outputting something on the command line. So it ended up suggesting that to us and we accepted it. Now again, I think it's asking us to press tab, and my guess is again it's going to segregate this part. So let's save this and let's start our terminal session. So let's start our application by UV running our main.py /help to check out all the commands. We can type /config to see our current model parameters. As you can see, we are using a non-reasoning GPT-4o mini model with 500 maximum tokens, 0.7 temperature, no instructional message, no conversational history. And this makes sense because we haven't yet sent any requests to our model, so there is no history. Let's set our instructional message first. Instruction will be you are an expert in geopolitics and history and always like responding in detail to user queries. Let's sanity check our configurations again. And as you can see, our instructional message has been set to system role because it's a non-reasoning model. So let us send first request asking our AI model what's the capital of Italy. And as you can see, it's constructing the instructional message here. Then it's adding conversation history, which currently we don't have any. It's just a system message. This is the response which we got from our AI model. Now let us ask it capital of Senegal, but this time we will not be asking it directly. We'll just imply that we are asking something about this country, Senegal. And our assumption is that if we are indeed passing our conversation history to the AI model along with our recent user query, then it should understand what we are asking about Senegal. Okay, let's press enter. As you can see, it has understood that what we are asking about Senegal was its capital. And the reason why it understood that is because if you look at our conversation history, it has system message, it has our first user question, which was what's the capital of Italy, and it has this AI response which will always have this role of assistant, and this is basically the message that we pass to our AI model. It has the system message, it has the first user message as well as the AI response, and then our final user message asking it something about Senegal. Look, if we did not pass this message to the AI model, it will not understand what we are asking about Senegal. The only reason why it feels AI model has memory is because we have explicitly forced it to remember remember what conversation we had before we asked it about the capital of Senegal. Let's confirm that again by asking it the capital of Netherlands. But again, we are not explicitly asking. And as you can see, our conversational history is even bigger now with the user AI combination of Senegal's capital. And as you can see, it has correctly inferred that we were asking it the capital of Netherlands. Just to re-emphasize this part, that if we don't pass in the conversational history, then it will not remember the previous conversation we have had. Let's quit this first of all. Let us give it the ability to forget our conversational history. In our chat config class, we will also have another method which will clear existing conversational history. And as you can see, we are using the clear method for Python list, which will clear whatever elements we have. Then it's suggesting us to use tab for our next modification. So let's see what it is suggesting. So so it added our newly added method of clearing history whenever we use reset command. That seems logical. So yeah, so let's start our application and test that part out. What happens when we clear conversation history and then we implicitly ask about the capital? Let us uv run main.py and our application has started. Let us sanity check our model configuration, add instructional message. So with our message set, we will sanity check our configurations. As you can see, no conversational history. Now let's ask it the capital of Netherlands, and it will respond with the capital. Now let's ask that of India. We still have our conversational history, so it should be able to understand what we are asking about India. And as you can see, it has correctly understood that we are asking about the capital of India. At this point, let us try to use reset command to clear the conversational history. But before that, let us use config just to confirm that we should have 4 messages in our conversational history. And as you can see, that is correct. So our first 2 messages will be the user AI pair for Netherlands capital, and the other 2 messages will be user AI pair asking for India's capital. Now let us reset this so it clears a conversational history, and then when we run config command again to check out our configuration, we don't have any conversational history now. Now if we ask it, see, we are asking it the capital of Senegal, but we are only implicitly doing it. We have not specified that the information that we are looking for is the capital of Senegal. So it will be confused now because it doesn't have any conversational history to rely on. It does have our system message. So it will respond with some information about Senegal, but it will be a bit more hazy and not specific because we don't have conversational history and we are not directly asking it for the capital. So this is a case of agent being stateless. There is no state, but we are kind of asking it the question as if it has remembered what we discussed in the past, but it has not. So as you can see, it has not specifically responded with Senegal's capital. It has responded with details because we had our instructional message set where the AI is supposed to respond like an expert in geopolitics and history. It has given us all the information about Senegal, it seems, but yeah, so see, it seems like it has not given us the capital of Senegal at all. So all the details except for what we were looking, because agent was stateless. It did not remember the conversation which we had previously asking for different capitals. So it has given us all the details about Senegal except its capital. Okay, so let's quit this part. And before I end this video, understand the data structure of messages that we are sending to AI models, because this will be very consistent even between different models, not just that of OpenAI, but that of Anthropic or that of other open source models. Every time we are passing messages to any AI model, they will generally tend to have a role, which is that of either system or developer, which will define larger instructions that will drive agent behavior. Then there will be a user role, which will define the request sent in by the user, and an assistant role, which will define the response we get from AI. And this data structure will largely remain consistent, okay, where we will have some kind of list of Python dictionaries that will be sending to the AI. There might be some differences, but if you understand this particular data structure well, you will be able to adapt to different models. Again, not just of OpenAI, but of any other company or any open source models also. So absorb and understand this data structure of messages that we are passing to OpenAI's GPT model in this case, okay? Also, another part which you have to remember is even though we did manage agent state in this case by passing conversational history along with our most recent message to AI model, we have done it in a way which is very crude, because what will end up happening in production, your conversational history will be extremely large. It will not just have few messages, or it will not even have just tens of messages. It might end up having hundreds of messages. You can easily imagine user spending about 8 hours talking with the same AI model in the same chat session. In that case, now you have to be more creative about managing agent state, because if you keep passing entire conversational history every time user is asking a new question in ninth hour of that conversation, then you will end up risking first breaking the context window itself, because your context window will have a certain limit, for example, say 200,000 tokens. And by the time your user has had 8 hours worth of conversation, you're risking breaking context window limit. Even if you're not risking context window limit yet, the AI response itself might end up becoming suboptimal, because what happens in a long conversation is maybe I don't really want to index on the first 6 hours of conversation as much as I want to index on the last 2 hours. Whenever you have long conversation between user and AI, what you want to do is you want to pass in conversational history from more recent part of the conversation and just summarize the history from the previous part. So we might decide that, okay, my first 7 hours of conversation, just summarize, and that will become my state. Maybe my 8th hour, the last hour of my conversation with AI, is what I want to pass fully. So it ends up indexing more on the recent conversation and not on the entire conversation. And then other than that, you also might want to manage agent state across different user conversations. So for example, if you have an application that is being used by a few thousand or tens of thousands of users, you don't just want to maintain agent state for every user session. There are some things which might be so important that you want to remember and maintain in the state across different users. This is still a very high level view of agent state, just so that you understand what we mean by stateful and stateless agents. But as our application becomes more complex, down the line, we will be spending more time maintaining the state, so you understand different aspects of it other than what we have already done here, which is still very crude. We need to do more than that to make it work in production. So just to summarize what we have discussed in this video is the agentic system that you are developing is going to be much more than the AI model itself. So the AI model that we have, OpenAI's GPT in this case, is going to be an entity that is capable of reasoning and it has certain innate raw intelligence. But the agentic system that we are developing will be AI model itself plus a certain framework that deals with maintaining agent state. More informally, you can think of agentic state as memory or learnings that we are managing across different API calls. And that second part is extremely important if you want to make your agentic systems work in production. If you don't manage state, or if you manage it improperly, your agents will not work in production, no matter how good the AI models are. Because while they will be capable of reasoning, they will not be capable of learning and truly functioning with autonomy if we don't manage states properly. Okay.